So welcome back to part 2 of 3.3.1. So solving by looking inside. It says Kenya. It says I solved David's equation in a much quicker way. She solved the equation 4 times x plus 3 equals 20 with an approach that she calls looking inside. Here's how she described her thinking about I said, I think about everything inside the parentheses as a group. After all, the parentheses group all this stuff together, and I think the content of the parentheses must be 5. So why must the expression inside the parentheses be equal to 5? So if we look at the original expression, which is pretty much 4 times x plus 3, right, equals 20. Now think about it. This is a multiplication, and then she's saying that she's grouping everything inside here. So why must the expression inside the parentheses equal to 5? So if you guys think about it this way, 4 times what is equal to 20, right? In this case, the what happens to be x plus 3. So therefore, the expression x plus 3 must be equal to 5. All right. And then that would be pretty much part B. It says write an equation that states the contents of the parentheses must equal 5 and then solve the equation. So did you get the same result as David's method? So again, we rewrite it, right? X plus 3 equals 5. Subtract 3 from both sides again, one step equation. So that's going to be equal to x equals positive 2. And of course, we got the exact same method, right? So, I mean, the exact same answer. So, yes, we got the same answer in 3 different ways. So, again, the first method was pretty much rewriting, right? We used the Schur property, and that was in part one, solving. And then the second method was solving by undoing, which was instead of like taking an extra step and multiplying things out, we decided to pretty much consider x plus 3 as a group, right? And then finally, again, solving by looking inside. And this is more about like thinking about the problem, right? Like if I look at this, is like 4 times what gives me 20, right? That's why I wrote it over here. It says write an equation that states that the content says write an equation that states the contents of the parentheses must equal 5. And then we got that again. And then we solved the equation, and then pretty much we got the same answer, right? So the next thing would be says the 3 methods. So match the names of the approaches of the left with the examples on the right. So rewriting, it says if 5 raised to the 8x is equal to 5 raised to the 24, then 8x must be equal to 24. I don't think that's rewriting. Subtracting is the opposite of adding. So for the equation 3 times x minus 7 plus 4 is equal to 23, I can start by subtracting 4 from both sides. I don't think that's rewriting either because again, when we did rewriting, we were doing pretty much the derivative property, right? We're rewriting the equation in a different way. So in this case, I would say the problem might be easier if I turn 4 times 2x minus 3 equals 31 into 8x minus 12 equals 31. So I would say this is pretty much number one. So one is C, looking inside. So you only have these 2 options. Now, if you notice on this one, they're just thinking about, well, okay, so if these two are the same, that means that these two must be equal. So that's their thinking here. So I would say that's looking inside. So this would be A. And then finally, undoing, right, which is subtracting is the opposite of adding. And that's one of the methods that we use. So again, we subtract 4 from both sides, right? We're going to get 19, and then we're going to uh, divide by 3 and so forth, right? So that would be B. All right, so let's try a couple. It says we're going to work on these. Use the truth property or draw area model to help you rewrite the products. Be sure to record your work for each step. Check your solutions. Okay. So here I have 5x squared plus 43 equals x minus 1 times 5x plus 6. So what I want to do is pretty much set up the area model. So I'm going to have that's not going to change. 5x plus 43 stays exactly. 5x squared plus 43 stays exactly the same. So I'm going to do this on this side. All right. And then we have uh, x minus 1, right? X minus 1 here, and then 5x plus 6. So that's going to be 5x squared, negative 5x, right? 5x times negative 1, and then 6 times x, you get 6x. 6 times negative 1 is negative 6. So this equals to 5x squared. Combine the like terms, 6x minus 5x is positive x, minus 6. All right. And then we want to start solving. So therefore, what we're going to do first here is we're going to subtract 5x squared from both sides. Right. Doesn't matter which side you start because if you guys notice, both of them are the same. So that one goes away. And you're left with 43 equals x minus 6. You add 6 to both sides. And we end up with 49 is equal to x. And again, if you guys switch these over, all right, as long as nothing changes, like if it was negative, it stays negative, it's fine. All right. So I would always rewrite the variable first and then the number. All right. So the next one, you have x plus 3 squared equals x squared minus 3. So what we want to do there is, again, we want to make sure that we are uh, first distributing, right? So let's see that. So first we're going to do this, the x plus 3 squared. Remember, that's just x plus 3 times x plus 3. All right. So we draw our box, and this is x plus 3, x plus 3. So x times x is x squared. X times positive 3 is positive 3x. And then 3 times x is also positive 3x. And then 3 times 3 is positive 9. So here we're going to get the left side, right? Let me rewrite it. Is going to be x squared plus 6x plus 9. And then this right here has to be equal to that. So that's x squared. And then distributes the negative 3 into both of these in here. That's still rewriting. So that would be negative 3 plus 3x. All right. So negative times a negative gives you positive 3x. Negative 3 times positive 1, you get negative 3. So here we want to keep simplifying. And in this case, that's where we want to solve for x. So the x squares go away. We subtract from both sides. We're left with 6x plus 9 equals negative 3 plus 3x. And then from there, you can subtract 3x from both sides. Make sure you're always putting the x's on the same side. And you guys have, I'm going to continue here. You can have 3x plus 9 equals negative 3. Subtract 9 from both sides now. We got 3x, right, equals negative 12. And then divide both sides by 3. So you get x equals negative 4. All right. And then the last one, we have negative 2 times quantity negative 2x squared plus x minus 5 equals 8x over 4y quantity squared times y times 1 over y to the negative 2. All right. So don't get scared if you guys see fractions. So here, first thing you want to do, if you notice, you don't have to use the box because I can just distribute, right? So negative 2 times negative 2 gives us positive 4, and then x squared, right? Attach the variable. Negative 2 times positive x gives us negative 2x. Negative 2 times negative 5, negative times a negative is a positive, so we get positive 10, equals, and then here, when you have a square, you have to distribute both into both numbers here, not just one. So you would like have 8 squared, x squared over 4 squared, y squared. All right. So you got to make sure that if there's parentheses around this, that you give it to everything that's inside of that. All right. And then times, if you notice, this one has a negative exponent, and we call that the reciprocal. So whenever you guys see a negative exponent, all you have to do is just pretty much flip it over. So that'll be y squared over 1. So in this case, we have y squared over 1. And again, here we can simplify the left side, I mean the right side. If you notice, you have a y squared on top and a y squared on the bottom, so that one actually goes away. And then over here, everything stays the same. So that's 4x squared minus 2x plus 10 equals 8 squared. 8 times 8 is 64x squared. And then 4 squared is positive 16. And then no more y's. So 64 over 16 is positive 4. So I'm going to simplify that. All right, let me continue down here. So we have 4x squared minus 2x plus 10 equals 4x squared again. Now here, if you guys notice again, we have 4x squared on both sides. So we're going to subtract 4x squared from both sides. All right. Remember, the side I'm referring to is always on the opposite side of the line right there. So this goes away nicely. You have negative 2x plus 10 equals, again, this disappears, but not necessarily. If there's nothing there, right, the value for nothing is always 0. So subtract 10 from both sides, and we're going to get negative 2x plus 10, equals negative 10. So you can use the other technique right here, the looking inside. Negative 2 times what gives you negative 10? So that would be x equals positive 5, right? Or if you divide both sides by negative 2, negative divided by negative is positive, and then 10 divided by 2 is still positive 5. You can always go back and like check your answers, right? You can substitute the value that you guys got into the original equation. All right. We will talk about that later, but it's an easy step that you guys can do. Substitute everything back in, and both sides always have to be equal to each other. All right.